want to do a little review on the lecture we had in BCH 2429, which is biochemical reasoning. So we are going to be looking at analysis of experimental data. Now, what actually are the objectives, at least for this phase of the course? We are going to be looking at analysis of experimental data. How we are going to do it is that we are going to look at errors of measurement, we are going to look at statistical treatment of data, then reporting the result of a research. Now, an experimental data is a set of information that are generated in course of carrying out an experiment or research, whether in the field or in the lab. These data are obtained by quantifying or estimating the values of variables, which can be in form of strings, numeric, video, or even audio. In other words, when we are looking at data, we are just looking at the information you were able to gather. It can be string, that is in words. It can be like you're looking at something like a questionnaire. You will write A, B, okay. In question, for a particular question, you write strongly agree. All those ones are not numeric values, they are strings. Okay, numeric values is when you have digits. Now, videos are what you can use as an evidence of the work you're doing, or even an audio. Now, let's also consider the different types of data. Let's consider the different types of data. Now, we say data may be grouped into four main types based on method for collection. We have observational, experimental, simulation, and derived. The form of research data you collect may affect the way you manage the data. For example, data that is hard or impossible to replace. Example, the recording of an event at a specific time and place requires extra backup. It requires extra backup procedure to reduce the risk of data loss. So you find out that there are data that when you get it once, you might not reproduce it again. We will talk about it when we get to that type of data. Okay, because every experiment is supposed to be reproducible, but there are ones, the recording, especially the ones that has to do with recording of events, you might not really get the specific amount of people that were there in the first place. So let's look at observational data. Observational data are captured through observation of a behavior or activity. It is collected using methods such as human observation, open-ended survey, or the use of an instrument or sensor to monitor or record information, such as the use of sensor to observe noise level at the Abakaliki/Funai Motor Park, Iwo. Now, what you're saying is that in an observational data, you make use of what you see, what you observe, okay? And it normally makes use of an open-ended survey. In the survey, you might not really restrict people in this kind of data. You don't restrict people, you may allow them the opportunity to answer the way they want. Okay. Now, because observational data are captured in real time, it will be very difficult, if not impossible, to recreate it if you lose it. Okay, because you're doing it in real time, it's what is happening on the now. For instance, if you're if you're checking noise level at motor parks, if you repeat that experiment, you can't get the same number of cars, you can't get the same number of people that are generating the noise, you can't get the same number of marketers, people that are buying and selling. With the example we have here, the motor park is just in front of the road. You can't even get the number of cars that are passing the road. So there are a lot of variables in this place. So when you lose that first data you created, it becomes too difficult to generate it. Now, second one is the experimental data. Experimental data are collected through active intervention by the researcher to produce and measure changes or create differences when a variable is altered. In experiment, it's all about measuring variables and trying to find the effect of the changes you are creating. So the experimental data typically allows the researcher to determine a causal relationship, or is typically projected to a larger population. This type of data are often reproducible, but it can be expensive to do so. Now, in an experimental data, in fact, when you have an experimental data and it's not reproducible, then something is wrong with that experiment, because the essence of an experiment is for it to be able to be reproduced at each time. So when you, as an experimenter or a researcher, when you actually generate your data, it is believed that some other person can use the same procedure you use to generate similar data. It might not be exactly the same, but it will be a similar data. Now, we have the simulation data. Now, when we talk about the simulation data, we say that the simulation data are generated by imitating the operation of a real-world process or system over time using the computer test model. In other words, in simulation, there must be a software or a computer program, that you can use to simulate the real-world process. For example, to predict weather condition, economic model, chemical reaction, or seismic activities. We have already some software, some computer programs that you can change variables and generate data. Okay, this method is used to try to determine what would or could happen under certain condition. The test model is used often as, or even more important than, the data generated from the simulation. So whenever you simulate or a data, you can also do a test model for such. So this data that you generate by simulation of some certain condition is actually the type of data you call simulation data. Now we have derived data stroke compiled data. Derived data involves using existing data points, often from different data sources, to create a new one through a source of transformation, such as an arithmetic formula or regression. This kind of derived data is the data you get. Maybe you have gone to the field and you are able to generate your raw data, and you enter your lab and begin to apply some mathematical formula to it. You see, when you apply a formula to generate a result, the result is different from the one you've gotten from the lab or from the field. So we call this particular type of data the derived data. So we say, for example, combining area of population data from Twin City metro area to create the population density data. Okay. Now, while this type of data can be used to replace, can be usually replaced if lost, it may be very time consuming. It can possibly be expensive to do that. So it's not good to lose data in any way. Whenever you lose your data, you're going to actually increase costs to to reclaim it. Now let's focus on our experimental data. Let's focus on our experimental data. There are three types of experimental data which we are going to look at. We have the raw data, and the raw data is the data or information from a research or survey that has not been analyzed statistically, whether the data is qualitative or is quantitative. So once you get your data from any work, that data is known as what? A raw data. Now, we have the quantitative data. The quantitative data are used when the researcher is trying to quantify problem or address the what and how many aspects of a research. You're looking at a research. What will this do? What will that do? So in such things, you have to quantify your parameters. Okay, and when you quantify your parameters, you're going to get value. So there is a quantity that you get from such data. We say it is a data that can either be counted or compared on a numerical scale. Example could be the number of first year students in at AIF9, or the rating on a scale of 1 to 10 on the quality of food served at Vegas Eatery. These data are usually gathered using instruments such as a questionnaire, which includes a rating scale, or maybe you're doing something on the weather, you can use thermometer to collect weather information. Now, the statistical analysis software such as SPSS. We are going to look at SPSS in the course of our study, and then we are going to look at one more statistical package. Okay, so SPSS is often used to analyze quantitative data. Now, the third one is qualitative data. Now, qualitative data describes the quality or characteristics. It is collected by using questionnaire, interview, or observation, and frequently appears in narrative form. For example, it could be notes taken during a focus group on the quality of food in Vegas Eatery, or a response from an open-ended questionnaire. Qualitative data may be difficult to precisely measure or analyze. The data may be in form of a descriptive word that can be examined for pattern or meaning, sometimes through the use of coding. Now, coding allows the researcher to categorize qualitative data and to identify themes that correspond with the research question, and to transform the quantity and to transform sorry coding allows the researcher to categorize qualitative data to identify themes that correspond with the research question, and to perform qualitative analysis, and then statistical analysis such as SPSS can be used. Now, what you're saying is that when we have a qualitative data, we must have a way in which we will code it. And when we code it in such a way and manner, we can then, after coding, we can then analyze it as a quantitative data. Now, let's also look at measurement and error. A measurement of an amount or anything is based on some international standard which are completely accurate compared with others. Generally, measurement of any quantity is done by comparing it with a derived standard with which they are not completely accurate. Therefore, measurement is a means by which one evaluates or quantify material or conditions or things. Then an error may be defined as the difference between the measured value and the actual or true value. Now, when we talk about error, we are saying that errors are not mistakes. Errors are not mistakes, because definitely everything you measure will have a certain percentage of error in them. Now, an error may be defined as the difference between the measured value and the actual or the true value. For example, if two operators use the same device or instrument for finding the error in measurement, it is not necessary that they might get the same result. They will get similar results. There might be differences between both measurements. The difference that occur between both measurements is what is referred to as error. Okay, that difference in measurement is what is referred to as error. Sequentially, to understand the concept of error in measurement, you should know that the two terms that define the error: the true value and the measured value. The true value is impossible to find out. The true value is impossible to find out the truth of the quantity by experimental means. It may be defined as the average value of an infinite number of measured values. In other words, you might get a true value by measuring that measurement so many times so that you find the average. Now, measured values can be defined as the estimate value of true value that can be found by taking several measurements. In other words, measured value is that one you measure. Okay, and we say you're trying to measure a true value now. And when you measure the true value, you now see that you are actually trying to represent the true value. Okay, so the measured value is what you normally get in an experiment. It might not necessarily be the actual or the true value because of the presence of error. Now let's look at types of errors that we can get. Types of errors. We have the gross error. Gross error are caused by mistake in using instruments or meters, calculating measurement or recording data results. In other words, whenever you're using an equipment that is not functioning well, definitely you're going to be talking about what do you call it, an error, and it's going to be a gross error. The best example of this error is a person or operator reading a pressure gauge of 1.01 Newton per meter as 1.0. It might be due to the person's bad habit of not properly remembering data at the time of taking down the reading, writing or calculating, and then present wrong data at a later time. This may be the reason for gross error in the reporting data. Such error might end up in calculation of the final result and thus deviating the result. Now we have a blunder, a final source error, that these errors are caused by faulty reading due to wrong value while recording a measurement, or misleading the scale, or forgetting the digits while taking readings. So these blunders should stick out like sore thumb if a person checks the work with another person. In other words, when you have a repeated values, you will also always find out this blunder. It should not be comprised in an analysis of data. Okay. Now let's look at the third one, which is really our focus, the measurement error. The measurement error is a result of the variation in measurement of a true value. Usually, measurement error consists of a random error and a systematic error. The best example of measurement error, if an electronic scale is loaded with 1 kilogram standard weight and the reading is the reading is 10,002. In other words, that is in grams. In other words, we are saying that the reading is 10. The reading is 10 point, or rather 1.002 kilogram. Now the measurement error will be 1002 grams. Okay, when you subtract them, the measurement will be 1002 grams, which is our measured value, minus the 1000, which is the true value, and you have 2 as the error. Okay, I guess you understand that. Now let's look at the measurement error and we talk about the types. There are 2 types of measurement error, and these 2 types of measurement error, we look at the systematic error and then the random error. So we are going to look at the systematic error first. Now, the systematic error are the error that occurs when a fault in a measuring device is known as the systematic error. So it is the system that you're using to measure. When it has an error, then you classify it as a systematic error. Usually they are called zero errors, a positive or negative error. This error can be detected by correcting the measurement device. These errors may be classified into different categories. So let's look at the categories of systematic error. In order to understand the concept of systematic error, let us classify or categorize these errors as 1, instrumental error, observational error, and theoretical error. We are going to explain these 3 terms. Now, instrumental error occurs due to wrong construction of the measuring instrument. This error might be due to frictions when there are problems with the measuring devices. Now, this type of error, including the loading effect or misuse of the instrument. The instrument might be good, but you might not use it properly. For instance, I mentioned this in class, when you have a weighing balance and then the maximum the weighing balance could weigh is 500 grams. And then you will now get, you want to weigh your rat, you now get a beaker that is weighing, let's say, 315 grams, and you use it to 0. Okay, now when you 0, you have taken away the ability of the weighing balance to weigh anything more than 300, because what it can really give you accurate on is when the total of what you're going to weigh is going to be within the 500 gram limit. So when you put a rat and the rat is 200 grams, it is definitely going to give you a wrong answer. Now, in order to reduce gross error in measurement, different correctional factors must be applied, and in extreme condition, instrument must be recalibrated. We talked about calibrating of weighing balance. Okay. Now, observational error, this, as the name suggests, this type of error occurs due to wrong observation or reading in the instrument, particularly in case of energy meter reading. The wrong observation may be due to what we normally call parallax. In order to reduce parallax error, high accurate meter are needed. Sometimes a meter is provided with a mirror or a magnifying glass that will zoom out where you're going to read from. Now, the last one is the theoretical error. The theoretical error occurs by simplification of model system. For example, a theory that is stating that temperature of the surrounding will not change reading of a chemical reaction, when actually temperature is a factor in chemical reactions. So these three terms affect um, the the categories of systematic error. Okay, now systematic error also, we say that systematic error also is the portion of error that remains constant on repeated variables. They remain constant. In other words, this error keep occurring as you're measuring using that measuring device. So we say that the errors remain constant on the same variables, and we say they are referred to as the accuracy of measurement. They are referred to as accuracy of measurement. Non-calibrated instruments can cause these types of error. A systematic error can be trickier to track down and is often unknown. Now, systematic error is often also called the bias in measurements. Okay, it's also called what? The bias in measurement. So we call it the accuracy, and we can still call it the bias. Now, when we look at maybe a distribution, the one in red is the distribution where X that has a systematic error, and the second one is when there is no systematic error. Now you find out that this error was able to shift the mean. Okay, it was able to shift the mean from, you find out the mean is supposed to be located somewhere here. The mean is supposed to be located somewhere here, okay, to this place, because that mean, that error is constant. So it is already adding up something to the values you are generating at a constant rate. So it's going to affect the mean. So you say that, notice that the systematic error does affect the average. We call this a bias. Okay. Now, for the random error, we say that random error are caused by sudden change in experimental condition and noise, and even the tiredness of the working person. These errors are either positive or negative. An example of a random error is during changes in humidity, unexpected change in temperature, and fluctuation in voltage. You see, we can't control this one. Okay, when the temperature suddenly drops, which happens so many times, you might come on a very hot afternoon and you start work. As you're working, on of a sudden the cloud changes and the rain starts and the environment suddenly becomes cold.
is going to affect the result, and it's something you cannot change as an individual. These errors may be reduced by taking the average of a large number of readings. So you're going to repeat this experiment over and over again to generate results that you're going to find the average. Now, this kind of type of random error, we have the environmental errors. Now, the environmental error occurs due to some external conditions of the measuring instrument. The external conditions mainly include the pressure, the temperature, the humidity, and also even the magnetic field around such instrument. Now, when you go to hospitals, especially when you're passing through the X-ray area, they will ask you to switch off your phones. Now, sometimes you might not know why, and the reason is that the radiation coming out from your phone might affect what is happening, in the X-ray machine, and that could be very, very disastrous because it might lead to death, especially where they are using the X-ray machine to treat cancer, especially they are trying to target some cells and destroy it with rays. Okay, now in order to reduce the environmental errors, we try to maintain humidity and temperature, to keep them constant in the lab by making certain arrangements. Now, ensure that there shall not be any external electrostatic and magnetic field surrounding that instrument. Some of you will even be working in the lab and you carry your phone and place it on the spectrophotometer. Sometimes when your phone rings, it affects the reading of the spectrophotometer. There is always some level of interference, so you don't try that. Now, we are still looking at the random errors, and we are saying that random error is the portion of error that varies randomly on repeated measures of the same variables. And this type of error, we always refer to it as precision of the measurement. Now, we still give you a definition of what precision means, but because random error is varying when you're repeating the experiment, you can call this precision. Remember, we said that systematic error, we can call it accuracy, but this one you call it precision of the measurement. Now, causes of random error, we've talked about that. Electrical noise and environmental factors. Random error are one of the easier to deal with because the measurement fluctuates around the true value. Now, if we try to measure some parameter x, the greater random error will cause greater random error will cause greater dispersion of the values, but the mean of x still represents the true measurement. The mean of x still represents the true. Now, when we look at the distribution, you can see that the line with green is the one with a random error, and the one with blue is the one without a random error. You find out that whatever the error is, the mean value still remains the same. The mean value still remains the same. Okay, so we notice that it does not affect the average. It does not affect the average. Sorry,